rational indices or fractional indices are effectively just surd form. We went through the reason in class, but really quickly, if you've got 9 to the power of a half, if you multiply by 9 to the power of a half, index law 1 says we've got 9 to the power of 1. That's 9. Anything that squares to give 9 must be the square root of 9. So therefore we can show that 9 to the power of a half is equal to the square root of 9, which is equal to 3. The rule that we use is that, let's use a as our base. A to the power of m over n is equal to the nth root of a to the power of m, and that's also equal to the nth root of a all to the power m. Now it's useful to be able to move between all three of those states, between index form, a to the power of a fraction, to surd form with a power outside the bracket, because different ways of writing it will make things easier to evaluate. We just need to be able to go from surd form to fractional index form and back, and use these skills to evaluate terms with fractional indices. So the square root of 13, if you want to write that with a fractional index, the power of 13 is 1. The order of the radical there of the root is 2. And that means we've got 13. The base of our fraction is 2. I'm sorry, I've lost my numbers. Sorry about the glitch, I lost my numbers there. We were looking at the square root of 13, and I was reminding us that the power of 13 there is 1 because there's nothing there, and the order of the root, since there was nothing there, is 2. 13 stays as our base number. The order of the root is the denominator, and the power of 13 is our fraction. Here you'll see that in the next example that both the 3, the coefficient, and the x cubed are underneath the square root sign, so we will need to deal with both of those separately. Just like when you raise product to a power, you've got the product under the square root here, you're dealing with them both separately. You could think of it, if you wanted, as root 3 times the square root of x cubed and deal with them separately. So the square root of 3 is 3 to the power of a half. We worked that one out in the last example. And now I've got x cubed under the square root. So I've got x, the denominator is still 2 because it's a square root, and the power of the x, 3, is the numerator of our fraction. The next example, 2 root 2, the 2 is not involved in the root there at all. This is just 2, sorry, the first 2, the coefficient. That's just 2, and the square root of 2 is 2 to the power of half. So I've got 2 times 2 to the power 1/2. Now because we've got the same base there of 2, and I've got the power of 1 there, the first index law says I can add those powers. So that's 2 to the power of 3 over 2, adding 1 plus a half. Sorry, write that a little better. 1 plus a half is 1 1/2, and if we write that, of course, as an improper fraction, 3 over 2. We can go from index form back to surd form. All you need to do is remember that the numerator is the power of the base number, and the denominator is the order of the surd. So I'll have a cube root here. 4 is the base number still, and the power is 1 because there's a 1 on top of the numerator, so I don't need to put that down. Here I've got 6 as my base number. My root is the 5th root because that's the base of the fraction, and that's 6 squared. And I would expand that out there to the 5th root of 36. We can use this to quickly evaluate terms. So I've got 8 to the power of 2/3 here. That looks scary, but it's not. Take it, I hope I've got enough space here. Just take it into surd form. So that's the cube root of 8 squared. Now, it's actually easier here to take that squared outside. The cube root of 8, squared. And the reason for that is that I've spotted that the cube root of 8 is 2. And so it's going to be much easier to get the cube root of 8, which is 2, and square it, giving me 4, than it would have been to square 8 and get 64 and then get the cube root of that. My last example, 3 to the power of -1/2. Notice that we're using all our index laws here because that's a negative power. I'm going to have 1 over 3 to the power of 1/2. And 3 to the power of 1/2 is the square root of 3. And at that point, if I wanted to evaluate it, I'd have to get my calculator out. I'd probably leave it like that just at the moment. So you do need to be able to move back and forward between index form and surd form and evaluate where possible.